Right. So children, we're going to learn about sets. What are sets, right? And how do you work with a mathematical set? So children, first we'll start with what is a mathematical set? All right. So children, remember a set is a collection of objects, right? Numbers, letters, or anything, right? A collection of objects is called a set, right? We use that in everyday language, right? So we say we have a set of plates, right? It's a collection of plates, right? So we have a set of clothes, we have a collection of clothes. So these are all sets, and here we are going to use the same set theory in mathematics for numbers and letters, right? That's what we are going to do. Then children, the objects of the set are known as elements, right? Now, it's a little different in mathematics. Now, if you take a set of clothes, the individual elements are known as clothes. But here we have a mathematical set where the individual elements and individual numbers or letters are known as elements, children, right? The word is elements, okay? In sets, children, there is a set language and a separate set notation which we have to learn. So we are going to do that today, right? We are going to learn set language and set notation, right? So children, what does a set look like? First, we have a look at some sets and see, right? So these are two examples of sets, children. So you can see this set A, the first one, has the numbers 1, 3, 5, 7, 9, and 11, right? So some odd numbers are in that set. The set B has the letters of the word Colombo, right? So it has the letters of the word Colombo, right? So you can see these are some examples of sets, children, right? So you can have numbers, you can have letters, right? All of these can be in a set, right? Then children, a set can be represented by a Venn diagram, right? You all know what a Venn diagram is, right? So you all have learned about Venn diagrams, I'm sure, in previous grades as well, right? So children, for example, if now this is set A that we took previously, remember, right? So this set A can be shown in a Venn diagram like this. So you can see we have a square, right, to represent the universal set. I'll talk about that a little more detail in a bit, right? And then we have set A shown by the circle, and all of the elements inside A, we put it into the circle, right? We put all of the elements.
Sandon teacher?
Yes.
Yeah, there is a question. Can you move to the other slide?
The previous one?
Yes.
Yeah, sure.
Yes, it cannot be repeated, Sandhu teacher. The same letter cannot be repeated in a set.
Ah, yes, this one, Colombo, isn't it?
Yes.
It's the O.
Yes.
That is true. Yes, that's correct.
Thank you, Maya.
Right. So good eye, good catch. Right. Okay.
No, actually, it's not me who did say. So
Yeah, that's what.
Omaya. Yes.
Yes.
Thank you so much.
Children are attentive. Very good.
Yes.
Okay. So children, as I was saying before, right, we have the oval, which is set A, and we have the elements in set A written inside this oval, right, or the circle. Okay. Then children, what are the elements of a set? So remember, we discussed that the individual numbers are called elements, right? So children, this symbol here, this E-like symbol, right, is used to indicate an element of, right? So for example, children, if this is set A, right, this is the same set that we used earlier, right? 3, and this symbol A means that 3 is an element of set A, right? That's how you say that 3 is an element of set A. So instead of writing it in words, children, in mathematical notation, you can quickly write 3 and this symbol and H means 3 is an element of set A, right? And children, if you want to say that something is not an element, you can use the same symbol with a small cross across it, right? A small line crossing it, right? So here it says that 4 is not an element of set A. You can see that 4 is not inside set A, right? So that is how you give the symbol of an element. Okay. Now children, the universal set, right? The universal set contains all elements of the related sets, children, right? So what does that mean? Now, children, let's say you have set A, set B, set C. So you have a lot of different sets, right? Remember, all of these sets are inside a large set that we call the universal set. So the universal set is the big set which contains all of these together. So children, imagine it like this now. Imagine that we have different planets, right? We have different planets are in the solar system. The solar system is inside the galaxy, and all of the galaxies are inside what? The universe, right? So it is the universe that contains all of these galaxies and solar systems and planets and stars and everything. So think of it like that. The universal set is the set which contains all the numbers in the related sets. Okay. It's commonly denoted by this letter here. You can see this Greek symbol. It is the letter lowercase epsilon. Now these days epsilon is very common because there is a new variant, I think, of COVID called epsilon, right? So you must have heard of this. So they name these COVID variants using Greek letters, children. That's why we have alpha, beta, then
Alphabet.
gamma and delta and
Delta.
all of this, right? So these are all Greek letters. The next Greek letter is epsilon, right? So this is how they name COVID as well. And this is how we name mathematical symbols as well, right? Okay, so children, now you can see if I have set A as 1 3 5 7 9, set B as 2 4 5 7, the universal set contains all of these elements. So you can see the universal set has 1 2 3 4 5 7 9. Everything in set A and in set B is all in the universal set. Right. So children, I'll show you this in a Venn diagram. If you look closely, you can see set A, and then we have set B, all of the things that belong to set B, and then we have the epsilon symbol on the outside. You can see this is the universal set, is the box with the black border. That is the universal set. It contains everything, right? That is the universal set, children. Okay, so I think that should be clear. Let's move on to intersection. So children, this is the symbol, this red symbol, like an upside down U, is used to indicate an intersection, right? An intersection contains only the elements that are common to both sets, children. So let's have a look. So let's say this is set A and we have set B. So children, the intersection is going to only have the elements that are common to both sets. So if you look closely, you can see the only numbers common to both sets are 5 and 7, right? So the intersection written as A intersection B with the intersection symbol in the middle is 5, 7. That is the set, right? So children, that region that they are talking about in the intersection is this one here. So I'll shade this for you. This is the intersection. Oh, I don't think that's very clear in yellow. Let me use another color. Right. So children, this is the set, right? That is the intersection, which contains both things, elements from both A and B, right? Okay, so let's go on. Right. So children, now the union. The union is given by this symbol. So it's like a U, right? It's used to indicate a union. A union is all the elements from both sets grouped together. So again, let's take two sets like this. So A is 1 3 5 and B is 2 4 5. So children, the union is going to have all of these symbols together, all of these elements together. So you have 1 2 3 4 5. Now remember children, you have the 5 is the repeated element. We don't repeat it, right? We don't repeat it. We just write it once. Okay. So that is the union. So if we look at it in terms of the Venn diagram, children, right? The union is going to be everything inside both the circles is the union. That is the union. So you saw the intersection was the middle section only. Union is both the sets together, right? Both the sets together. Okay, so I hope that's clear. Then children, the number of sets in an the number of elements in a set. Now this is important, right? This is common in questions, right? The number of elements in set A is denoted by n and then A in brackets. So remember this notation, children. right? This notation is important, right? So when they say n and the name of the set in brackets, that means what is the number of elements in set A, right? So for example, children, if we use this set A, right, n of A, so that is number of elements of set A is 6, because you can see if you count, you have 1 3 5 7 9 11, that's 6 elements, right? So that means the number of elements in set A is 6, right? So children, make sure you write this notation down, make sure you remember it. It is really, really important. I have seen questions in your past papers where they say show this in set notation. So when they say that, you have to say n of A or n of B and then write the number of elements in that set. Okay, right, so let's move on. So children, what is a subset? Set A is a subset of set B if all elements of A are also elements of B. So what does that mean, children? That means if everything in A is also in B, right? That means A is a subset of set B. Okay, so that the notation is the U, which is sort of tilted on its side, right? So let's say set A is 1 and 3 and set B is 1 2 3 4 5. So children, won't you agree when I say that everything in set A is also in B? Because you can see in set A you have the elements 1 and 3, and in B you have 1 and 3 and more elements, right? So that means A is going to be a subset of set B, right? So children, in a Venn diagram form, this is how you will show it, right? So you have set B, it is the big blue circle, set A is the smaller red circle. So children, if it's a subset, that when you draw it in a Venn diagram, set A will be inside set B, right? That's how you will show it. Okay, so okay, I have a very good question from Sanuda. Sanuda is asking, sir, is every set a subset of the universal set? Yes, Puta, that is a very good observation. Every set is a subset of the universal set because every set takes elements from the universal set. So you are absolutely correct. That's an excellent question, right? Every set is a subset of the universal set. Yes. All right. Good. Okay. So then the complement of a set, right? So children, what is the complement of a set? Children, the complement of a set are the elements not found in the set, right? So the complement of set A is given by A complement. So that when we say A complement, children, the way you write it in mathematical notation is you write A, the name of the set, and then you write an apostrophe or a dash after it, right? That is how you say A complement is A and a small apostrophe or a small dash, right? So that is A complement. So children, imagine the universal set is 1 2 3 4 5, right? So the universal set is 1 2 3 4 5, and out of these elements in the universal set, set A has 1 and 3, right? So the universal set has 1 2 3 4 5, set A has 1 and 3. So if you want to say what is not in set A, so children, what is not in set A? 2 is not in set A, 4 is not in set A, 5 is not in set A, right? So that means, children, A complement is 2 4 and 5, right? Because those are the elements that are not found in set A, right? Those are the things that are not in set A. Okay, so if you were to show this using a Venn diagram again, children, you can see you have the universal set in a box, right? And inside the box you have set A in a red circle, right? Children, the complement, A complement, is going to be everything outside this red circle. So I'll shade this region for you. This is the region. That is the complement. Complement is everything outside it, right? Everything outside is the complement of the set. Okay, so I think that should be clear, right? Next, children, finally, a null set. What is a null set? Children, a null set, also known as an empty set, so both these words are interchangeable, right? You can say null set or empty set, is a set which contains no elements, right? So children, there can be a set which is empty, doesn't have any elements. And children, the symbol for a null set is this. You can see a zero like symbol with a line going across it, right? So that is the symbol for a null set. or you can put the two curly brackets with nothing in between. That is also null set. All right. So how can we get a null set? Let's have a look. Now, children, let's say you have the sets A 1, 3, 5, set B 2, 4, 6. Right? Can you see, children? These two sets have nothing in common. Right? Set A doesn't have any of the elements set B has. Set B doesn't have any of the elements set A has. So if you take the intersection between these two, children, right, there is nothing in common. So the intersection between these two is the empty set or the null set, right? So keep that in mind. Also, children, another thing to note is, right, some mistake a set with only 0 for a null set, right? This is a common mistake, children, right? This set has one element, this set has the element 0, right? The null set has no elements. So if you have a set which has two curly brackets and a 0 in the middle, children, right, that is not a null set. That set has one element and that element is 0, right? But an empty set has nothing in it, so just the two curly brackets, right? So that's something to keep in mind. Also, children, finally, now I don't have a slide for this, but I just remembered it now. Something that's really important is this, right? Keep in mind, sometimes in questions, children, they'll give you Venn diagrams like this, right? They'll give you a Venn diagram, say this is A and this is B, and they'll give you the different numbers in here. So say you have 5 and so on. So say you have, okay. So children, you can see that we have several numbers in here, right? So you will get Venn diagrams like this. So this is pretty clear, children, right? So the elements in set A are 1, 2, 4, 5. The elements in set B are 3, 5, and 10. And the elements in the intersection are just 5. And the elements outside both A and B are 7 and 11. This is clear. Children, sometimes they will give you Venn diagrams, and in the question they will specifically tell you that what you have in the Venn diagram is the number of elements in each set, right? Don't confuse that with this. So for example, children, they'll tell you that this has 2 elements, this has 5 elements, this has 10 elements, and there are 7 elements here. What this means is, children, right, what this means is, so say this is set C and this is set D, right? Here, children, what it means is the number of elements in C is 7. Not that 5 and 2 are elements of C. That is not the case. Don't confuse these two types of Venn diagrams. I'll repeat it. One type of Venn diagram you will get is you will be shown the different elements that are in that set. That is the first type with A and B. The second type of Venn diagram they will give you is they won't show you the individual elements that are in set C or in set D. Instead, they will tell you there are 5 elements in C only. There are 7 elements in C in total. There are 2 elements in the intersection. There are 10 elements in D only, and there are 7 elements outside both C and D. So here they are not saying that 5 or 2 or 10 and 7. These are not elements. These are the number of elements in that region, children. Keep that in mind, right? These are the number of elements in that, children. It's very important to understand this difference, right? Is this clear, children? If you understood this, can you put your hands up so I know? Did you get this, children? You understood the difference very clearly? Okay, good. All right. So children, now this is the end of my, this is the end of the slides, right? If you
Yes,
have any
somebody is
questions,
asking some.
yes, go ahead, children.
Yes, who is asking some question? Anuja?
No, madam, I just all understood.
Okay.
Children, any questions? Before now, next I will give you the questions sheet. So before I give you the question sheet, are there any questions that you have to ask? Any questions about sets? Children, any questions about sets? Or is it, if it's clear, tell me that it's clear. Is it perfectly clear?
Excuse me,
Yes, Putta.
Yes.
sir. Should we hand draw the Venn diagrams, or should we use a protector for those circles?
Don't waste time. Yeah, you can draw it the way you want. If you
Yeah.
want to draw nicely, then you can.
Yeah.
But what I'm telling is, don't waste time in the exam, because time is very, very important. Because no one is going to check your circle whether it's nice or not. Right? You
No,
can
if
just
for the
hand draw.
square, maybe you can use a ruler. That would be reasonable.
Yeah,
But
yeah,
to draw the circle, Putta, don't go into so much trouble.
yeah.
Right?
Don't worry.